Today we're doing Math 6, Mission 6, Lesson 16 and 17. All right, Lesson 16 says, two related quantities, part 1. Let's use equations and graphs, so we got to pull out graph knowledge again, to describe relationships with ratios. All right, which one would you choose? Be prepared to explain your reasoning. Would you choose a 5-pound of jug of honey for $15.35 or 3 1.5-pound jars of honey for $13.05? So there's lots of different reasonings for things, right? Maybe you go with the 5-pound because you need 5 pounds of honey, because 1.5 plus 1.5 plus 1.5 times 3, right, is actually 4.5. So maybe you go with the 5-pound because you need 5 pounds of honey. Maybe you want the best price per pound, right? Or maybe you want just the lowest price. So the lowest price would be 3 for $13.05. So that only gets you 4.5 pounds, whereas the 5-pound one is $15.35. So let's see what our unit price is, right? So let's bring this down to 1. So we have the pounds and we have the price, right? So here it's 5 pounds for $15.35. Now, how do I get this down to 1? Well, I divide by 5. So I'm going to divide this side by 5. So 5 goes into 1 0 times. 5 goes into 15 3 times. Bring down the 3. 5 goes into 3 0 times. Pull that decimal up. That's 0. 3. Bring down the 5. 5 goes into 35 7 times. And that's 35. And we are done. So the unit price here is $3.07. Let's see what the unit price is for the 3 small jars. So we have pounds and we have money. So this is 4.5 pounds for $13.05, right? So here we go. $13.05 divided by 4.5. So we got to move the decimal over, bring that decimal up. 45 goes into 1 0 times, 45 goes into 13 0 times, 45 goes into 130 2 times. 2 times 45 is 90. And that leaves us with a 40. We bring down our 5. 45 goes into 405. Well, 10 would be 450. That's very close. So let's try 9. So 45 times 9. 9 times 5 is 45. Carry the 4. 9 times 4 is 36. Plus 4 is 40. Look at that, 405. So that's 9. So this is actually $2.90. So per pound, the 3 1.5 jars of honey costs less money. So these are just different ways to explain why you would choose one over the other. No one answer is correct, okay? All right. We're just trying to remind you how to do equivalent ratios here, because we're going to use that today. All right, let's go on to activity 1. Lynn needs to mix a specific color of paint for the set of the school play. The color is a shade of orange that uses 3 parts yellow for every 2 parts red. So we have a ratio of 3 to 2, yellow to red. Complete the table to show different combinations of red and yellow paint that will make the shade of orange Lynn needs. All right, so we know we have 2 cups of red paint and 3 cups of yellow paint. The total cups of paint. So how much does that make? Well, when you put 2 cups and 3 cups in, that really gets you 5 cups, because you have 2 cups of red, 3 cups of yellow. It's going to get you 5 cups of paint because you put 2 cups in and 3 cups in. Okay? So we just add those together. Now let's see here. we need 6. Well, how do you go from 2 to 6? Well, you multiply by 3. So what are you going to do to the 3? Multiply by 3. 3 times 3 is 9. And then we're going to add that together. 9 plus 6 is 15. But look, this 5, we can also multiply by 3. So everything gets multiplied by 3, and we get the answer 15. Okay, let's keep going. 20, we could do, how do you get from 5 to 20? 5 times what gets you 20? Well, 5 times 4 gets you 20. So 3 times 4 is 12, and 2 times 4 is 8. 8 plus 12 does equal 20, so those are correct. All right, let's go to the next one, 18. Well, I can do 9 times 2 to get to 18. So then 6 times 2 is what? 12. And so 12 plus 18 is 30. And if we went from 15 times 2, that would also equal 30. All right. Let's keep going. We have 14. We know 14. Well, I know how to get from 2 to 14. 2 times 7 is 14. So 3 times 7 is 21. 14 plus 21 is 35. And I know 5 times 7 is 35. So that works out. All right, let's try the next one. 16. I actually know 8 times 2 gets me 16. So 12 times 2 is 24. What is 16 plus 24? That's 40. And if we do 20 times 2, we get 40. All right, the next one is 50. Well, I know 5 times 10 gets me 50. So 3 times 10 gets me 30. And 2 times 10 is 20. 20 plus 30 equals 50. Okay. Then we have 42. So how do we get to 42? Well, I know 21 times 2 gets me 42. So 14 times 2 is 28. So we're going to add those together. 28 plus 42. Oh, gotta wait for my PDF to save. Is 70. And I know that 35 times 2 equals 70. So we're good to go. All right, let's look at 2. Lynn notices that the number of cups of red paint, so the number of cups of red paint, is always 2/5 of the total number of cups. Well, that makes sense because red in this first line here has 2 out of the 5 cups, right? So we could say this is 2 out of 5, right? 2 out of 5. Oh, look, that's 2/5. She writes the equation R equals 2/5 T to describe the relationship, which is the independent variable, which is the dependent variable. All right, so we need to discuss what independent variable is and dependent variable. All right, so if we scroll down, they should have this in here. Okay, they do not give you a good description of that. So we're just going to come up with them. The independent variable is the one that affects the dependent variable. So the dependent variable depends on the independent variable. Okay, so what that says is our R in R equals 2/5 T, right? Our R is our dependent variable because it is affected by the T. So R is the dependent variable. The T is the independent variable because we need to plug in T in order to find R. That's what it's saying, okay? We must know T to find R, okay? So then 3 says, write an equation that describes the relationship between R and Y, where is where is Y the independent variable? I think it's asking us just to make Y the independent variable, okay? Yeah, these two right here should be switched, where Y is the independent variable. So the independent variable is T, so Y needs to be there. So we have to do R equals something times Y, okay? Now R is the red paint and Y is the yellow paint. So we need to look at this. When R is 2, what is Y? Well, Y is 3, okay? So when you have 2 red cups of paint, you have 3 yellow cups of paint, right? So R equals 2/3 times the yellow paint. So whatever the yellow paint is, R is going to be 2/3 of the yellow paint. And we know this because we need to be able to get one or the other, right? Yeah, so how do you get from 2 to 3? You divide by 3/2, which gets you 2 times 2/3, right? So this is, you have 2 out of 3, 2 cups of red for every 3 cups of yellow, okay? And basically what, oh, it's gonna save. Basically what this is asking is if we have yellow paint and we have red paint, our yellow is 3 cups and our red is 2. 3 times what is going to equal 2? Well, that's 3 times 2/3, right? Because 3 times 2 is 6 and 1 times 3 is 3. 6 divided by 3 is 2. So that's how we get from 3 to 2. Okay, and that's what we're trying to solve. 2/3 times what gets you, times yellow paint gets you red paint, okay? Your dependent variable is always going to be the variable that is alone, okay? So this is our, oops, that's not what I wanted. This is our dependent variable. This is our independent variable. So when we go to 4, it says write an equation that describes the relationship between R and Y, where R is the independent variable. Okay, so remember, the variable that's alone is the dependent variable, and we want R as the independent variable. So when I write this, Y is going to be on this side, and then something times R is going to get you Y. Well, when we had red and yellow, we had 2 cups of red for 3 cups of yellow. So 2 times what gets you 3? because that's what we're saying here. Something times r equals y. So when r is 2, what times 2 gets you 3 because y is 3? Well, I need to get rid of that 2, so I have to multiply it by 3 over 2. Right? Because 3 over 2 times 2 over 1, 3 times 2 is 6, 2 times 1 is 2, 6 divided by 2 is 3, and our y is 3. So here, y equals 3 halves times r, where r is the independent variable and y is the dependent variable. Okay. Let's keep going. Use the points in the table to create 2 graphs that show the relationship between r and y. Match each relationship to one of the equations you wrote. Okay, so we're going to look, and it doesn't matter which one. It does. So this says cups of red paint, and this one says cups of yellow paint. Okay, so whatever our red paint is, we are going to plot that one on the x-axis. I should probably use red for that. Here. And then whatever our y is, we're going to plot it on the y-axis. Okay, so this is what this looks like. When I had, oh look, and this goes up by 4s. So when I had 2 cups of red paint, red and yellow. When I had 2 cups of red paint, I had 3 cups of yellow paint. So 2 cups of red, 3 cups of yellow. Where do those come together? Right here. So I'm going to plot a point there. I'm going to zoom in so you can see that better. Okay. Then when I had 6 cups of red paint, well, how did I get from 2 to 6? I multiplied by 3. I had 9 cups of yellow paint. So 6 cups of red to 9 cups of yellow. So this is a 6, this is my 9. I follow those lines until they cross, and that's where my dot goes. All right? When we had, let's see what another one was. 8 cups of red. We had 12 cups. So 8 cups of red, 12 cups of yellow. When we had, what do we want to do? 12 cups, we'll do the next one. When we had 12 cups of red, we had 18 cups of yellow. So I go to my 12 here, and I go up until I find my 18, and I plot that point. And look how cool this is. We can draw a line that goes through the dots and continues on. Okay? All right, so Y is yellow and X is red, right? Red. So which one works with this? Well, this plot is 2 to 3, and this one is 6, 9. This one is 8, 12. Those are my coordinate points, right? So which equation goes with this? Is it r equals 2/3 times y, or y equals 3/2 times r? Well, we have to know what our slope is. And I know this is a lot, but for slope, it's how many you go up versus how many you go over to get to the dot. So here we go up 3 over 2. All right? So up 3 over 2. Here we go up 3, 6 over 2, 4. 6 over 4. Look, what does that reduce to? 3 over 2. So which one has 3 over 2 in it? Is it r equals 2/3 times y or y equals 3/2 times r? It's y equals 3/2 times r. So this one equals y equals 3/2 times r. That's the equation that matches this graph. Now let's do the other one. So we have cups of yellow here for my x-axis now, and we have cups of red for my y-axis now. Okay, so we've switched it. So cups of yellow paint will come first. Well, I have 3 cups of yellow paint. 3 cups of yellow paint to 2 cups of red. So there's my first one. I have 9 cups of yellow paint to 6 cups of red. I have 12 cups of yellow paint to 8 cups of red. I have 18 cups of yellow to 12 cups of red. So here again, I have my line, all right? And so we want to know how much we go up versus over. This is called rise over run. So I go up 2 over 3. So that's 2 over 3. So my equation here is r equals 2/3 y. Okay? So please make sure you're reviewing your lesson summary. This one's really important to review. So we can see from the table that r is always 5/3 as long as g, and that g is always 3/5 as large as r. So when we go this way, that is 5/3, and when we go this way, it's 3/5. Okay? So in this equation here, if g changes, r is the one that gets affected. So if I plug in 2 there, r is going to be different than if I plug in 6 there. Okay? So that means that g is our independent variable, and r is our dependent variable. Okay? And this is the opposite. All right, let's go on to lesson 17. 2 related quantities, part 2. Okay. Our warm-up says, Lynn and Jada each walk at a steady rate from school to the library. Lynn can walk 13 miles in 5 hours. Oh, we just got a ratio, 13 to 5, right? 13 to 5. And Jada, and that's Lynn, Jada can walk 25 miles in 10 hours. Oh, we just got another ratio, 25 to 10. They each leave school at 3 o'clock and walk 3 1/4 miles to the library. What time do they each arrive? Well, in order to do that, we need to get our miles to 3 1/4. And right now, this is miles, this is time in hours. Let's call it hours. And this is miles and hours, right? So we have 13 and we really needed to get to 3 1/4. Well, the easiest way I know how to do that is to get everything down to 1 and then go up to 3 1/4. So that's what I'm going to do. 13 down to 1, I divide by 13. So I'm going to divide 5 by 13. And that leaves me 5 over 13 because a fraction is division, right? And then I need to go from 1 to 3 1/4. Well, that's multiplying by 3 1/4. So I'm going to multiply 5/13 by 3 1/4. 3 1/4 is 3 times 4 is 12 plus 1 is 13. So I have 13/4 times 5/13. Oh, and look at that. I can cross reduce. 13 goes into 13 once, 13 goes into 13 once. So that means leaves me 5/4. So it takes her 5/4 of an hour. So that's 1 hour and 1/4 of an hour. And 1/4 of an hour is 15 minutes. So it takes Lynn 1 hour and 15 minutes. So she would get there at 4:15. Now let's go over and do Jada. So for Jada, I go from 25 to 1, I divide by 25. So I need to do 10 divided by 25. And that gets me 10/25, which I can reduce because 5 can go into both of those. 5 goes into 10 twice. 5 goes into 25 5 times. So that gets me 2/5. Okay, then I need to go up from 1 to 3 1/4. So I have to do 2/5 times 3 1/4. So that would be 13/4 times 2/5. 13 times 2 is 26. Hold on, but I can cross reduce. Let's cross reduce this. 2 goes into 2 once, 2 goes into 4 twice. There we go. So that's 13, and then 2 times 5 is 10. So 13/10. I don't really know what 13/10 is translated into an hour. Like I knew 1 and 1/4 is 1 hour and 15 minutes. So let's look here. 10 goes into 13 once, and that leaves me 3/10 of an hour. So I definitely know Jada goes 1 hour, but how many minutes is 3/10? Well, I know there are 60 minutes in an hour. So if I have 10 here, if I get this to 60, then I'll know how many minutes that is. So 10 times 6 is 60, so 3 times 6 is 18. So that means I have 1 hour and 18 minutes. So that puts her at the library at 4:18. Okay? So that's how that works. Equivalent ratios. That's what we're doing. Let's look at the next activity. Diego, Elena, and Andre participate in a walkathon to raise money for cancer research. They each walk at a constant rate, but their rates were different. Complete the table to show how far each participant walked during the walkathon. Okay, well, we have a lot of missing parts like last time. So we're going to have to look. I know my time in hours is 1, but that's all I know for that line. Here, I know 2 and 6, so I know how to get from 2 to 1. I divide by 2. So 6 divided by 2 is what? 6 divided by 2 is 3. So miles walked by Diego in an hour is 3. I can definitely do that. I know that 3 times 4 gets me 12. So 1 times 4 is 4. So this time that's missing is 4. I also know I can go from 1 to 5 by multiplying by 5. So 3 times 5 is 15. So I've now filled out all of Diego, and I also know my time in hours, which is awesome. So I know, 2, that to go from 4 to 1, I need to divide by 4. So to go from 11 down to here, I divide by 4, and that gets me 11 divided by 4, or 11/4, right? Now I could do 11 divided by 4, right, and see what that is. 4 goes into 1 0 times. 4 goes into 11 2 times, that's 8. And that leaves 3 with a decimal, 0. 4 goes into 30 7 times. 7 times 4 is 28. It's 2, 0, bring it down. 4 goes into 25 times, that's 20, 0. So 11/4 is the same as saying 2.75. So we can say that. Now, I know to get from 1 to 2, I multiply by 2, so I'm going to multiply 2.75 times 2. So that's basically doubling it. That's 10, 14, 15, 4, 5, and I have 2 behind the decimal, so move it over 2. That is 5.5. Okay, and then to go from 1 to 5, I multiply by 5. So I'm going to take this and multiply by 5. So 2.75 times 5. 5 times 5 is 25. 5 times 7 is 35. 36, 37. 5 times 2 is 10. So that's 13. And I have 2 behind the decimal. So this is 13.75. Okay. Now, miles walked by Andre. Okay, so the only thing I know about Andre is that in 5 hours, he walked 17.5 miles. Now, how do I get this down to 1? Well, I can do 5 divided by 5 to get to 1. So I'm going to do 17 divided by 5. Okay, so 17 divided by 5. 5 goes into 1 0 times. 5 goes into 17 3 times. That's 15. That's 2. Bring up the decimal. Bring down the 5. 5 goes into 25 5 times. So this is 3.5. Now, how do I get from 1 to 2? I multiply by 2. So 3.5 times 2 gets me 7. And how do I go from 1? Oops. Close. Low battery mode is fine. How do I go from 1 to 4? I multiply by 4. Or how do I get from 2 to 4? I multiply by 2. So 7 times 2 is 14. All right. So 2 says, how fast was each participant walking in miles per hour? I'm just grabbing my charger really quick. There we go. All right, so miles per hour, we can look just at this line to see how far they walked in an hour because the time is 1 hour. So Diego walked 3 miles per hour. Elena walked 2.75 miles per hour. And Andre walked 3.5 miles per hour. And that's so easy because all we had to do was look at this line. All right, let's keep going. How long did it take each participant to walk 1 mile? Ooh, so we haven't figured out 1 mile, right? So I want to know how long it took Diego to walk 1 mile. Well, how do I get from 3 to 1? I divide by 3. So what am I going to do to this one? I'm going to divide by 3. And that leaves me with 1/3. So how long did it take Diego to walk 1 mile? Oh, it took him 1/3 of an hour. Okay. Okay, let's look at Elena. Now, Elena, we have to go from here to 1 mile, right? So how do I go from here to 1 mile? Well, I divide by 11/4. So I'm going to divide 1 by 11/4. And 1 divided by 11/4, we're going to keep, we're going to change, and we're going to flip. Oops, not 10. 4 11ths. And that leaves me with 4 11ths. So it took Elena 4 11ths of an hour. And then Andre was at 3.5 down to 1. We would divide by 3.5. So that's 1 divided by 3.5. Now that's a little tricky. It doesn't, because we don't want to mix fractions and decimals, right? So instead of doing 3.5, 1 divided by 3.5, we're going to change this into a fraction. So that's 3 1/2. And 3 1/2 becomes 3 times 2 is 6 plus 1 is 7, 7/2. Okay? And then dividing that by 1 divided by 7/2, we keep, we change, we flip. So that equals 2/7. So it was 2/7 of an hour to walk 1 mile. All right, graph the progress of each person in the coordinate plane. Use a different color for each participant. So here we have time, and here we have distance. Okay? So time, we're going to have 1, 2, 4, and 5. For Diego, we're going to have 3, 6, 12, 15. For Elena, we're going to have 2.75, 5.5, 11, and 13.75. And for Andre, we're going to have 3.5, 7, 14, 17.5. Okay, so I'm going to use red for Diego. So in 1 hour, he went 3 miles. In 2 hours, he went 6 miles. So I'm going to find my 2 and I'm going to go up to my 6, right? So it looks like this and this where they cross, right? That's where my dot is going to go. Then I have 4 hours for 12 miles. So here's my 12 and that's my 4. And then in 5 hours, he went 15. Now, I don't have a 15 on here, but I have a 14, then I have a line, then I have a 16. So this must be 15, okay? All right, so this is Diego's line. And here we go, we're gonna go. That was terrible, but. We should be able to. Let's try that again. Because these should all line up better than they are. I am a terrible line drawer, apparently. Anyway, this is the way that they go. Oh, you know what? I can use this. Let's try this. I don't think these line up very well because they should all touch. I don't think. Oh, that's what I did. This is on 5.5 and not 5. So 5 and 15. There we go. Now let's look at that. Yes, there we go. So here is Diego's. And I still missed that one a little bit, but that's okay. You get the idea. All right, now let's do Elena. So Elena, I'm going to use blue. Okay, so her first one, her hour, was 2.75. So here's 2, that's 3, so I'm going to do 2.75 there. Now for 2 hours, she went 5.5. So here's 5, here's 6, I'm going to go halfway through. For 4 hours, she went 11. So here's 4. And there's 11. And then in 5, she went 13. So here's 13.75 right there. So again, hers is also a straight line. Why are you disappearing on me? That gets really, really close to Diego's line, but then starts to veer away from Diego's line as we get further out, right? Because she is going slower than Diego. And Andre is actually going faster than Diego because in an hour he goes 3.5 miles. So here we go. In 1 hour, he goes 3.5. In 2 hours, he goes 7. In 4 hours, he goes 14. And in 5 hours, he goes 17.5. All right, so there, if I use this, like that, there's my Andre line. Okay, so you can see the differences between the three. Okay, Diego says that D equals 3T represents his walk, where D is the distance walked in miles and T is the time in hours. Explain why D equals 3T relates the distance Diego walked to the time it took. So distance is our dependent variable, and T is our independent variable. So each hour that Diego walks, and each hour is our T, we have to multiply it by 3 to get us the distance. Right? Because if he walks 1 hour, we multiply it by 3. Oops, and he is my red. We multiply it by 3 to get 3. If he walks 2 hours, the distance he goes is 6. If he walks 3 hours, which we didn't actually do, but we could, if he walks 3 hours, the distance he goes is 9. Right there. Okay? So the distance is 3 times whatever the time is. Okay? B says write 2 equations that relate distance and time, one for Elena and one for Andre. So again, for Elena, her distance is going to be equal to however far she goes in the time, right? So in 1 hour, Elena went 2.75. So guess what her multiplier is? 2.75 times the time it takes her. Because in 1 hour, she goes 2.75. So in 3 hours, we would do 2.75 times 3 to see what it is. And that, it looks like it could be 8. 2.75 times 3 hours. That's 15. 21, 22. 6, 7, 8. 8.25. So it's right here, which that line does hit. So we're good. And then for Andre, this is Elena, Andre's distance is whatever his time or his distance is for 1 hour, which was 3.5. So we would do distance equals 3.5 times his time. So if we wanted to figure out how long it took him for 3 hours, how far did he go in 3 hours, we would do his distance for 1 hour times 3. So that's 15. It's 9. That's 10. With 1, so it'd be 10.5. He would travel 10.5. And look at this. Here's 10. Here's halfway through 10. Yeah, 10.5. You can see it on Andre's line. Okay, let's do 6. Use the equation you wrote to predict how far each participant would walk at their same rate in 8 hours. So we plug 8 in for T. T equals 8. Okay, so for Diego, that would be D equals 3 times 8. For Elena, so this is Diego. For Elena, we would do D equals 2.75 times 8. And then for Andre, we would do distance equals 3.5 times 8. So let's do that. 3 times 8 is 24. So distance for Diego is 24. For Elena, 2.75 times 8 is, let's do it, 2.75 times 8. That's 40. That's 56 plus 4 is 60. Hmm. 8 times 2 is 16, plus 6 is 22. I have 2 behind the decimal, move it over. There we go. So this distance is 22. And for Andre, 3.5 times 8, 3.5 times 8. 8 times 5 is 40. 8 times 3 is 24, plus 4 is 28. 1 behind the decimal, move it over. His distance is 28 miles. Okay? See how we're just plugging in whatever t is for t? For Diego's equation and the equations you wrote, which is the dependent variable and which is the independent variable? So the dependent variable is always the one that's by itself. So distance is the dependent variable because it depends on what t is. Like t in this case was 8. When we were doing it, oops, I don't know what I just did there. When we were up here, we did 3. So distance was dependent on 3 instead of 8. Down here it was dependent on 8. So that means that time is our independent variable. Okay? All right. Please review your lesson summary.